Thank you, Rashan, for the invitation. I do appreciate it. And I also appreciate you putting on this webinar series. The topic of invasive pests is so important to us in the Hawaiian Islands. And it's really great that you're doing this to improve our awareness. And I think also to help us to become more collaborative. Once we know the research other people are doing, we can find more collaborators. We need to join together as a team to fight these very challenging problems, whether it's invasive weeds or invasive insect pests like little fire ant, coconut rhinoceros beetle, or two-line spittlebug. We need to take all the tools that we can to work together to help manage and stop the spread of these invasives. So today I'll be discussing the use of entomopathogenic nematodes as part of an integrated pest management approach to do just that. A big focus of it today will be on this insect that you see on the screen, Queensland longhorn beetle. So I'm glad to hear that there's a lot of Hawaii Island people joining, because I think you'll find that this is a really important issue that we're dealing with right now. Now let the show begin. So as I was saying, working at PBARC is a really great opportunity for me, and I really enjoy the work. We're really stakeholder driven here. We really care what's going on with the growers, the ranchers. Whenever they have a problem, they will come to us. We'll get together with other scientists in the facility and try to come up with solutions to help them control these pests, improve their profitability. And that's really our goal here. And I've never felt that my job was more important than it is nowadays with just this onslaught of invasive species that we're dealing with. If I can change the slide now. Okay. So for those of you who haven't had talked with me before, we're going to just do a quick introduction about what a nematode is. It's one of the most abundant and diverse multicellular animals on Earth. There's 30,000 described species, and I'm sure there's hundreds of thousands of more that haven't been described yet. They fill every ecological niche on our planet. They include plant parasites, insect parasites, human and animal parasites, as well as free-living nematodes, which a lot are marine nematodes, and there's also nematodes that are in the soil. They feed on fungi, bacteria, and they're really important decomposers and important for our soil health. And they're also used as soil health indicators by some of my colleagues. So today we'll be focused on insect parasitic nematodes, which are microscopic, non-segmented worms. They attack insect hosts. They have a very broad host range. They're easy to apply, and they're safe for animals, humans, and plants, which is very important. They're not regulated by the Environmental Protection Agency. They don't require any personal protective equipment, and there's also no re-entry when you apply these as a treatment. So how do these tiny little worms control insect pests? Well, they work together as a team. They're like a giant army. They have leaders and followers, and the leaders will go out and search for a host, an insect host, and then they will enter into the host, and they have a symbiotic bacteria which is released. And from there, the insect will die of sepsis. So then the nematodes will begin to develop, they'll reproduce, and after a generation or two, the infected juveniles will emerge and start the process all over again. So entomopathogenic nematodes can be bought on the store shelf in the mainland and in other countries. But here in Hawaii, it's very important for us to protect our beautiful ecological resources. So there's a lot of restrictions on importing in microorganisms. Entomopathogenic nematodes are one of those that we can't import these products and just buy it on the store shelf. There's a lot of entomologists here at PBARC, and they encouraged me to think about using these organisms to control invasive insect pests. Especially Dr. Robbie Hollingsworth was very interested in using them as a biological control and as part of his integrated pest management program to control pests. So we decided to go out and try to hunt for some that were here in Hawaii. We followed in the footsteps of Dr. Arnold Hara and Dr. Harry Kaya, who back in 1991 scoured all the Hawaiian Islands looking for these nematodes. So we took their paper, we went and we went in all the same places, and we found all the same nematodes still there in those exact locations. That nematode was Heterorhabditis indica, which we found on all the main Hawaiian Islands. And these nematodes exist in the coastal regions. So this photo is of Kathy Mello and her husband, Joey, who helped to do a lot of these surveys. And I think they had a lot of fun going around to all the beaches in the state, collecting all these wonderful samples. The nematode that we're currently using is from Hilo, that we use here on the Big Island, and it was collected at Hilo Bay. And the exact location is not shown in this picture, but trust me, that's where we get our nematode from. So the strain we're using here is HM264. It's highly virulent against a broad host range. And these nematodes are active hunters. They cruise through the soil following chemical cues from prey. And we've tested them against about 40 different invasive insect pests, including small hive beetle, banana moth, Malaysian fruit fly, coffee berry borer, and most recently, two-line spittlebug. And of course, like most experiments, when you start off in the lab, everything works great. You know, they usually can kill insects, in petri dishes at 100% mortality. So then we'll move on to greenhouse trials or simulated field trials, and it looks pretty good. But then once you get out to the field, there's a lot of challenges. And it's a big world out there. There's predators, there's bad environmental conditions. And so really to use these nematodes, you need to have kind of the perfect system where everything, works right. Mostly these nematodes are used against soil-borne pests, because these nematodes are from the soil, and that's where they want to be. So above ground applications, sometimes they'll get tricky and want to go back and return to the soil. So one of our big success stories has been the management of sweet potato weevil. This weevil, the adults will cause pinholes on the sweet potato tuber when they oviposit and put the eggs. Then the larvae will feed on the inside of the tuber, and this will cause a lot of internal damage and a very bitter taste, which makes these tubers unsellable, and you will have resulting in a lot of culled sweet potato tubers, which are left in the field, and then subsequently that's just increasing the population of the sweet potato weevil. So the experiments that we did, we found that these nematodes will actually travel into the sweet potato tuber and hunt down and feed on these larvae. We did some simulated field trials, and we found a 77% reduction in the sweet potato weevil populations when we applied the nematodes. And that didn't matter if the tuber was completely buried, if it was half buried, or if it was just laying, as long as it had contact with the soil surface. The nematodes follow these chemical cues from the insects and hunt them down one way or the other. So we were very excited about the results of this study, which is quite excellent for a biocontrol agent. This resulted in a NIFA grant on organic sweet potato integrated pest management in collaboration with Dr. Kunwi Wong of CTAR and our colleagues at Auburn University to run field trials using these EPNs and cover crops. So today, the star of the show, or may I say the nemesis, is Queensland longhorn beetle. This is a large wood-boring cerambycid with an unbelievably wide host range, which seems to be growing by the week. The larvae cause extensive structural damage, which has actually caused mortality in many trees. I hear people telling me all the time they don't see kukui around Hilo anymore. And it's because kukui is one of the favorite hosts of this insect pest. So this beetle has got its name, we call it Queensland because that's where it came from. But believe it or not, in Australia, it's not even on their radar. So there's enough, predators and parasites there that this beetle doesn't cause the damage that we're seeing here. The symptoms will be like sawdust-like frass, from the beetles, the larvae feeding. The tree will respond by oozing out sap. You'll notice the bark will be lifting from the tree. And then once you get the girdling of the trunk, then it's too far gone at that point. And then on top of that, oftentimes we'll see this in combination with feral pig damage, which also will girdle the outside of the trunk. And it's been really devastating for the growers here. After all of this damage is done, the larvae will develop into an adult and leave to go and reproduce and start the cycle again. So you'll see these shotgun holes in the tree, and then that means that the larvae has completed its life cycle. So this is some of the damage you'll see in orchard crops. It started out, we've seen a lot on citrus, kukui, and cacao. So the larvae will create galleries within the tree. They start very small, right underneath the bark of the tree. And as they grow, they go deeper and deeper into the branches and the trunk. This can cause girdling, and you'll have like branch dropping off. Like this quite devastating damage. So one of the problems with this pest is it's so cryptic. It's hidden inside there, so it's very difficult for us to find a way to control it. I know some people have been spraying like avocado or doing imidacloprid drenches for the avocado lace bug, but when these treatments are applied for this other insect pest, it doesn't even touch this beetle, this Queensland longhorn beetle, because it's not usually feeding on the vascular system. So it's just living its life in these trees protected with no way for us to manage it. So I'm just going to show you a few photos. I just couldn't believe some of the damage. This is a giant starfruit tree, complete mortality from the QLB damage. And you can just see the splitting of the trunk and the branches. It'll even go on crops as small as passion fruit. Now this really surprised me, but we did see terrible damage on the passion fruit collection. And cycads is a big one. And this was where we first started seeing, many years back. Nobody really knew what it was, but they did see like queen sagos toppling over. They were getting a lot of damage on their cycads. And the thing is, it's so moist inside of these plants that the larvae just love it. And this photo on the bottom was a giant queen sago palm that had toppled over, and we just reached in with one handful and just got so many larvae out. It's quite devastating. And on top of that, it's also become a quarantine pest. These beautiful cycads were on their way to Lanai, and the inspectors at the Hawaii Department of Agriculture and Biosecurity noticed the symptoms of the QLB larvae inside. So fortunately they caught that, but very difficult for the grower because they were unable to sell this material because they couldn't do an inter-island transport. And not only that, they lost a lot of the trees to this devastating beetle. You can see it just tunneled in the inside and just eats the whole inside out. It's really awful. And if that wasn't bad enough for our farmers, I got a call from the Department of Forestry, the University of Hawaii at Hilo, and the Hawaii Army National Guard, who have a collaborative project over at the Keauka'a Military Reserve. They have like a lowland reforestation project, and they started noticing a lot of damage on the kukui trees, and then on our native Hawaiian tree, the alahei. So this photo shows the exit hole of the Queensland longhorn beetle. And you can see that the bark has lifted and started to fall off, and it's all rotted underneath. And when we get this kind of damage, the ambrosia beetles, which is the tiny little holes, they are come in as a secondary pest, and because they're realizing that the tree is damaged. So this was very sad. It's not just our farmers that are affected, but it's also our forest. And I get a lot of community members too saying, the devastation in their own backyards, their citrus and avocado trees. So we were wondering, could we use nematodes to control this pest? So it started out a few years ago. We just said, well, let's just try like a small assay. We cut a bunch of branches off of a kukui tree that was infested with the QLB, and we tested Botanigard, the nematodes, and then a combination of Botanigard and the nematodes. So you can see from that cut log that they do go in quite deep. So this is one of the reasons it's difficult to control. The photo on the bottom, you can see a live QLB larvae in the background, and then that dark brick red shows the nematode infected larvae. So we were excited after only 12 days. We split the logs. We wanted to see what happened. We were getting around 55% control with the nematodes, which was promising. So we said, wow, we really need to look into this further. Unfortunately, Botanigard didn't have much effect, and we didn't really see a synergistic effect from combining the treatments. And it's really because the nematodes are the stars here because of their active hunting ability, that they're going to go into those galleries and hunt the larvae down. So then we thought, how can we actually do this in field trees? We were trying different techniques, like spraying the trunks with the nematodes. Then we would try to wrap it, and contain it in there so that would kind of force them in. But then Kathy came up with this great idea to use a nematode application using a plastic syringe needle. So this is similar to the syringe that you would use if you were vaccinating livestock. You can, pick that up at your local feed store. We were using a 16 gauge, 1.5-inch needle, and then we wanted to actively just insert the nematodes into the trees. They have nowhere to go, and the only thing that they can do is look for food inside the tree and hunt those larvae down. So we came up with a technique that we've been sharing with growers, and this, I'm going to go through just a few of the steps on how you would do this. First of all, you have to store your nematodes in a dark, cool location until your application and use as soon as possible. I really worry that sometimes the growers, if they're not taking good care of them, when you apply the nematodes, if they're either dead or they're not as fit as they could be, that's really going to affect the efficacy. So it's really important to take care of your nematodes and keep them protected. Do not refrigerate. On the mainland, the products, you do refrigerate it to extend the shelf life, but these nematodes, remember, came from the beach. So they like being warm, but just not in direct sun. We found that the best results are when you apply the nematodes early in the morning, at dusk, or on rainy days. This really is so cool. Your nematodes aren't going to overheat, and neither are you. So if we're out there getting soaked and we're getting really wet, I know that the nematode treatment is going to work excellently that day. Another important step is to remember to agitate the nematode solution before you transfer it to the beaker. And every time before you draw it up into the syringe, you need to agitate or stir it with a glass rod, because the nematodes like to settle very quickly. So you want to get an even amount. You just keep it stirred up. So the first step, before you even put your nematodes outside, is you need to go through your orchard and scout it for QLB damage. This is a very important step, and it takes some time. You need to look at the trunk and all of the branches from every angle, every tree. And when you see something, then you just want to tie it off. So you want to look for those symptoms that I mentioned, the sawdust-like frass, the oozing sap, the girdling of the trunk, lifting of the bark. What I like to do is the first step is I like to look at the bottom of the tree, and you see in the picture on the left, you see that pile of frass. Then I know, yep, it's this active infestation right now. And then you can look up from there and see where that those frass and sawdust is dropping from. Then you can find kind of the entry holes. Oops. Okay, so here's Kathy showing how to do the scouting. This is a very common symptom where you sign, you see it coming out, see how it's the sawdust. See how she's pressing it there? That is a very, very spongy section. So underneath there is completely hollow. So that'll be a great place to inject the needle, because you could put the needle right through. You're going to get it right into the gallery where it needs to be and deliver the nematodes right to the larvae. So you want to help your nematodes out by applying it as many locations as possible, because you're not sure where they are at that time. So here's the needle. We're putting it into that area where the frass is coming out, getting the nematodes right where they need to be. And you can see it's raining when we took this video. So this is perfect nematode application weather right here. And then the next step, you go to the next spot, go to that spongy area, feel where you can. If the needle doesn't go in, there's not any larvae underneath there. It's going to be really hard. These are hardwood trees. So you have to find those places. And I know it's tedious, and I hear from the growers all the time, this takes a lot of time. And yes, it does. But right now, it's the only thing we have once your tree is infested. It's the only option at this moment. So I would just hope that whoever's watching this, researchers out there, please use your expertise to help us come up with more ideas, more solutions for ways that we can control this terrible pest. So the first trial we did, we went to Debbie Ward's place. She was an extension agent at CTAR in the past, and she was very excited for us to try to use these nematodes at her farm. She was having a bad infestation on kukui and also on her citrus. So we went out there and applied. Then it was kind of the end of our fiscal year, then the holidays. So we didn't make it back out there until January, and it had been 4 months, and we could not believe what we saw. We were so excited. There were no new signs of QLB activity, no fresh shavings, frass. The tree was actually healing on the wounds and getting new growth. And that was great. She was so excited. We were so excited. And I think we're pretty sure what happened here is when one QLB larvae is infested with nematodes, it's going to produce approximately 200,000 to 400,000 effective juveniles. So that second generation is inside of the tree, and that's 10 times more, than we applied initially. And they have nothing else to do but go and search for larvae. They're trapped inside the tree. So it's really the second and third generations that are finishing the job and going after all the additional QLB larvae in the tree. And that's what makes it successful, is the nematodes are trapped in there. And all they can do is search for the larvae. So then we went out to the USDA's germplasm repository, and it's a great place for us to test out these nematode applications. We started with avocado, and we saw that 1 month after we did 2 monthly applications of the EPNs, 75% of the infested avocado showed no more signs of recent QLB activity. We also tried this on the cacao. After one application, 50% no longer showed the active infestation signs, which was great, but we never could get a handle that season on the other 50%. And I believe that the reason was they were severely infested by the time we got out there to work on them. And the larger the larvae get, the harder it is for the nematodes to kill them. So it's going to take more nematodes. They also have a lot of avoidance behaviors. They will ball up the sawdust and try to block the gallery so the nematodes can't come in. Also, they're much stronger, and the immune system is more difficult for the nematodes to overcome. So you need to get out there, check your fields, treat as early as possible. As soon as you see that little tiny signs of the nematodes, of the larvae feeding, you need to start the nematode treatment as soon as possible. And one thing I should have mentioned on those videos was when you see the large shavings, that is also showing you that is a very large larvae in there. So you just want to start early before they get that big. So this whole project has been really stakeholder focused. It's been difficult to validate with experiments because how cryptic it is, and no one really wants you going to their farm, cutting down all their trees so you can get mortality counts. So we've just been focused on getting the outreach to the growers and seeing and getting the responses from the growers, which has been so positive. We've went to a lot of farms. We did a lot of in-person trainings. We've done online trainings. We've worked with the Hawaii Tropical Fruit Growers Association, the chocolate growers, also the Hawaii Ulu Co-op, have all been very receptive to this management technique and helped us to share it and get the information out. So it just got more and more calls all the time. It just got too much for us to handle. So we got a material transfer agreement in place and partnered with the Big Island Invasive Species Council, who assist us with the EPN rearing and distribution to growers and community members. And they provide these nematodes at no cost to the growers. So now one of the bottlenecks that we're having is ramping up on the production of these EPNs. It's a lot of work to rear them. We have to use insects hosts. So we have to raise insects, which is the most work. It's easy raising the nematodes, but raising insects is much more challenging. I am working with a fellow scientist here at PBARC, Charlie Mason, who's trying to optimize a mass rearing protocol so that we don't need the insects. We can raise these in the laboratory. So once we can get that optimized and scaled up, that'll be really helpful for us to be able to provide nematodes on a regular basis to all the people that need them. So if you're interested in getting some of these nematodes and you're on the Big Island, please contact Jade Miyashiro or Darcy Yogi at the Big Island Invasive Species Council, and they will work on getting you a little kit. They will provide you with a canister of nematodes, the needle, and the syringe, as well as an instruction pamphlet on how to do the application. So I've also tried training some growers on how to rear the nematodes themselves, because that would be great if anybody is interested in doing that. This is how we do it here at PBARC. We use a Galeria. They're kind of like the model host for rearing the nematodes, but this is what it looks like. It's kind of an intensive rearing. You need to keep all the stages separate. You need to keep making diet. You need to keep it mite-free, fungal-free. So keeping it clean is the #1 priority. That makes it pretty challenging for most people to rear it. So we also will recommend mealworms. It's a lot easier to rear, but they're smaller and they're hardier, and they don't produce as many nematodes as those nice juicy Galeria. So if any farmers, you have access to any like soft-bodied larvae, most likely they will be a host for the nematode. And if you had something readily available that you could inoculate, that would be a good way to keep your cultures going. And so this is what it looks like when we're extracting the nematodes out from the insects. This is actually QLB larvae and adult. And this is what we call a white trap. But you can modify this at home. The most important thing is you just have a little pedestal of some sort to keep your cadaver out of that pool of water. You can use coffee filters to lay the cadavers on top, and you wet them. And when the nematodes exit the body, they will crawl along this moist filter and then drop into the water. And then that's how you extract them. So you see, raising the nematodes is much easier than raising the insects. And this is how we store them. Main thing, we just keep them away from the light. You just pour that water off. We use a vented container, and don't overfill the container because it needs to have proper aeration, or you can definitely suffocate your nematodes very quickly. And you also have to be very cautious when you're when the nematodes first emerge from the cadaver. If there's too many in the water, they can also suffocate. So all of this, it takes a lot of time, and you really have to be paying attention to each step of the way. But if anybody's interested in learning some more about this, please reach out to me. So now I'm going to switch gears and not talk about nematodes for this final bit. It's just because, like I said, nematodes is just one part of what we hope to develop an integrated pest management program. And ideally, you don't want the larvae to even get into your tree, because then you're just trying to combat something that's in there already doing damage. So we partner with Dr. Pascal Adelor from the University of Hawaii, CTAR, and we looked at ways to discourage the females from laying eggs underneath the bark. So I heard about a lot of growers out there who've been painting their trees with hydrated lime or latex paint, And people would always ask me about it, but I just said I never tried it. So I was like, well, maybe we should, just pivot for a little bit and try to focus on this and see if there's some way that we can discourage the females from, just laying eggs on your crop. So we decided we would just do a little log test to start out and see how these products responded. We tried latex paint in water mix 1-to-1, kale and clay, which can be purchased as surround. We also did a hydrated lime and added 100% neem oil. We did a 3-in-1 plant guard application and also tried Daylin protective tree wrap. So I saw this, it was online. It was a product that they carry at Ace and Home Depot on the mainland. And I was interested in trying it. It's made of iron oxide, limestone, and diatomaceous earth. And there's a lot of different kind of essential oils mix that are added. And so it's used as a sunscreen, an insect repellent, and a rodent repellent. So here's a photo of someone who has painted this plant guard in their orchard. And then on one of their advertisements, they had this cute little bunny chewing on it, and says it tastes horrible. So that looked promising. And then this one I also found online, which is also carried at your local garden stores, called Daylin Protective Tree Wrap. And the idea is it's an insect pest control. The insects can't get under it or lay eggs. It's non-toxic, and it's a chemical-free alternative. But, it is a physical barrier, so you would have to go out there and wrap every tree. So here we are in the greenhouse, setting up this trial, painting the logs, letting them dry. And this was our choice essay. Do each of the different treatments in a box, introduce 3 females to each box, and we have it in multiple containment enclosures because these guys are going to try to chew their way out if they're not happy. And this is what it looked like. After a few weeks, the chewings, and then also in the top right, we did a no choice trial where we just had each treatment in its own Tupperware just to see what would happen. And then this picture on the bottom is a little QLB chewing on the plant guard treatment, saying it tastes yummy. And so here's the results. In the no choice trial, we didn't see any statistical difference because, of course, they had no choice. But overall, they did seem to love the plant guard very much, which I hated to see that because I really liked it as a potential application. It was very easy to apply. It smelled great, and it was just very simple. So here's where we start really seeing the differences in the choice trial. We saw that the plant guard and the latex paint had a lot of eggs and larvae after the trial was over. And on this trial 1, the kale and clay and the wrap had the fewest amount of larvae and eggs. And in trial 2, the lime and the neem had the fewest amount of eggs and larvae. But the kale and clay and the wrap did well also. So the latex paint, they loved it. They really did chew a lot on the latex paint. So I would not recommend using latex paint. And please do not mix neem oil with latex paint because that is going to cause a chemical reaction, which can be damaging and phytotoxic to your trees. So that's not really an option. I like the plant guard. I do want to test it with neem oil in the future. But the QLB also likes the plant guard. In the past, the inventor of this product told me that they did used to use neem oil, but because it was becoming more regulated, that's when he switched out to the other essential oils. So kale and clay looked really good. It's easy to apply. You can use a pump sprayer. That is great. The lime and neem were good. I thought the lime was a little hard to apply. You have to get the consistency just right or it'll get very cakey. Um, and I really like the protective tree wrap, which you can see this photo here. I wrapped an avocado tree, and everybody kind of laughs at me about this one because they say no growers will do this, and they made me wrap that tree by myself to see how long it would take. And I think that took about 10 minutes and $10 to do that. And of course, you can't get the wrap in the upper canopy. But one thing you could do was, if you monitored consistently, if you see any damage in the upper canopy, you can either remove that infected branch, or else you could do the nematode on all before it goes into the trunk. The most important thing is to try to prevent that larvae from getting into the trunk of your trees, the main trunk, because once it's girdled, you're past the point of no return, unfortunately. So the next step, this was just a little log trial, so I'm not recommending anything right now in the field, but we are going to continue on with this work and test the longevity of the products in the field. I think I left the wrap on for a few weeks, and it was great. It was still intact when we went back, and when I unraveled it, it didn't seem to be doing any damage to the tree. Even though when I was applying it, I thought I might be choking it out with the pantyhose. But we're going to work on this some more. I think this would be a good to trying to prevent this pest from coming in. So finally, I just want to say to everyone that invasive insect pests are hurting our agriculture community and our natural environment. I really hate when I go to talk to growers and they just want to quit already, because it is discouraging when you see a majority of your trees are infested and there's no easy management solution. So I know applying the nematodes is not easy, but I just try to tell them to, please try it and stick with it. If you could just do a few trees a day, start just every early morning, go and, treat a couple trees, that would help, would really help a lot. So I hope that I've gotten some researchers on the line interested in this pest. We could really use your help. We need to find more solutions, and we need to all work together to really combat these pests.